Hello everyone, my name is Lena Brüggemann. I'm from Vista Remote Sensing and Geosciences, and my topic is crop yield modeling in agrivoltaics. In the context of climate change and a growing world population, resilient energy and food production systems are of great importance. Agrivoltaics, or APV, refer to the simultaneous use of land for both agricultural food production and PV energy production and have the potential to provide several synergies for both production systems. In agrivoltaics, the PV modules are arranged in a way that allows for the use of agricultural machinery in between, next to, or under the PV modules. In addition to differing spaces and PV module layout, differences respecting the crops grown, the soil conditions, and the climatic conditions are known to affect crop yields. Therefore, a framework for simulating impacts of APV shading effects on crop yields is needed for both farmers and APV planners. The crop yield prediction is based on Vista's own PROMIT model and includes the newly developed APV light simulation. This geometric light simulation tool, Vista Agrivoltaic Shading Model, modifies the direct and diffuse irradiance for observation points with a 10 cm spacing for each hour, which corresponds to the temporal resolution of the PROMIT crop model. PROMIT is capable of simulating spatially distributed land surface processes, such as actual land surface water and energy balance, dynamic vegetation development, soil moisture, soil temperature, and soil nutrient dynamics from the field scale to the global scale. The PROMIT crop model has been validated in several studies in the past and is regularly used on an operational basis for yield prediction products for different regions and climate conditions. Radiative transfer within the vegetation's canopy is handled within PROMIT, which requires top of canopy direct and diffuse irradiance input data, among other meteorological inputs, for the entire growing season. Thereby, the implications of agrivoltaics regarding light limitations and energy fluxes, including crop evapotranspiration, are taken into account. The model is capable of simulating shading effects for fixed tilt APV as well as one-axis tracking APV, using a fixed angle or angles determined by the single-axis tracking algorithms backtracking and true tracking from PV-LibPython. The Vista Agrivoltaic shading model was developed to fit the specific needs of the crop model. It uses geometry-based approaches to estimate direct and diffuse irradiance for the whole growing season in the required temporal and spatial resolution in a computationally efficient way. APV-modified direct irradiances are calculated using PROMIT solar position algorithms in combination with line-plane intersection to determine the shaded areas on the ground. The diffuse irradiances altered by APV are determined using spherical geometry to estimate the sky area blocked by the PV modules for every simulated point within the field. How does this affect the crop model? When observing one point in the field, you can see that the direct irradiance changes with agrivoltaic shading. In this example, we look at a point located 120 centimeters next to the PV module center. At 10 a.m., the observed point is not shaded. At 2 p.m., it's completely shaded. The diffuse irradiance is also slightly reduced due to PV modules partially blocking the sky. The modeled APV configuration shown here consists of 50% 1 in portrait trackers 1P and 50% 2 in portrait trackers 2P, both east-west tracked using backtracking to increase energy yields. In order to estimate the effects on crop yields in advance, simulations were conducted for winter wheat, spring barley, and rapeseed for the years 2007 to 2020. Simulations were carried out using downscale meteorological ICANN-EU data. As you can see on the slide, crop yield pattern matching the light distribution was observed for all crops in the simulations. Yields were more heavily influenced in areas directly below the modules and were closer to reference yields in the middle between two rows of trackers. When comparing the results for 1P and 2P, there are larger areas with crop yields drastically reduced in the 2P case. This results from greater light limitation effects due to larger impacts of shading caused by the much larger PV module area when compared to 1P. However, in both cases, the crop yields in areas directly below the PV modules are irrelevant to the farmer here, as they will not be used for crop cultivation in the future anyways. Due to required safety distances for agricultural machinery, these areas will be converted to green stripes instead. Excluding these strongly shaded green stripes, spatial means of winter wheat yields were reduced on average by 6% for the 1P design and by 16% for the 2P design. Simulating multiple years assures a statistical robustness and accounts for interannual variability. From the farmer's perspective, when looking at the crop yield for the whole area under agricultural cultivation, yield reduction due to loss of area caused by PV structures and safety stripes has to be further considered. The results suggest that for crop cultivation with 1P trackers, yields remain within an acceptable range. For the layout with 2P trackers, however, crop yields decrease more drastically. For some crops, cultivation with 2P trackers might not be feasible at this site at all. However, with climate change, the limiting factor could potentially shift from light availability to water availability in the future. Therefore, further simulations using climate model data are currently in the planning stage. The ProMate crop model has been validated in several studies before and is in use at Vista for yield prediction purposes on an operational basis worldwide. With the addition of the APV shading model, this expands ProMate's capabilities even further. In order to support farmers and APV planners in their decisions, the presented simulation framework is capable of determining the change in crop yield under APV for different crops. A quantification of yields for different PV module layouts is possible. Further potential arises with regard to modeling climate change impacts on APV and PV electricity yield simulation, which could possibly be included into the data products in the future. Thank you very much for your attention.